Alright class, so this is a little tutorial of how to complete the homework and just to make sure that you understand what's going on. So, when we see compounds, they're always going to have two names. The ones we've looked at so far are ionic compounds. That means they have a metal and a non-metal. In this case, our metal, so our first step is to figure out our metal. Now, you're going to look at your periodic table and see what charge it forms, or if it forms more than one charge. So if we look at cesium, we see that it only forms a +1 charge, which means that we can just draw one simple particle for cesium with just a plus in it. So you don't have to put the +1 there. Oxide, we know, and we've done that 1,000 times already, is a -2. So we're going to draw a -2 charge. Cesium, we're going to need 2 of those to make cesium happy, or sorry, to make oxide happy. So we got to have them equal out. So the total positive charge, which in this case now is +2, has to equal out the total negative charge, and that's how we know, what our formula is. So, cesium, the symbol is Cs, and I'll just use color to show you where the subscripts go for the formula. So, that's a 2, and when it's just by itself, you don't have to write anything. So we leave the subscript blank for oxygen. So our chemical formula for cesium oxide is CS2O. Moving on. Next one. All right, these two are interesting because it's kind of a trick. I want you to psych out, right? Because tin can be tin 2, or it can be tin 4. And obviously the psych out is that's supposed to be a 2, but it's not. So take a look. The first thing you need to do is look at the formulas. And what's cool about the formulas is they show you how many to draw. So that's our metal. Leave these guys blank. When they can be an option, just leave them blank to start. Okay? Fluoride is a negative. Just one negative. So from there we have 4 negatives, so that means that it has to be tin 4 right there. A +4. So we call this thing tin 4 fluoride. Now, the psych out here is you want to call that next one tin 2 because the 2 in that position there, but it's not. Okay? So we look at this guy here, and that's sulfur, so that's sulfide. And each sulfide is a -2. So we see that we have a total of -2. So this also is a tin 4 as well. And you can write your Roman numerals either capital or lowercase. I don't care. Some books, most books, and the jars that we looked at last day were in the capital Roman numerals, as long as you get them right. Okay? And if you forget your Roman numerals, that's found on the class notes, which are also on the blog. So there's your 2 names for those guys. All right. So again, when you have an option with the metal, leave it blank until you've taken care of the non-metals. All right. Lithium oxide. This one's pretty straightforward. Okay. Lithium. Since there's no brackets, means there's only one ion. Okay, so that's just a plus. And oxide, as we know and are quite getting familiar with, is a -2. We can just go right to that. So there's our oxide and our lithium. And lithium has a charge of +1, so it's going to take 2 of those guys, so our formula is Li2O, lithium oxide. All right, iron 2 nitride. Okay, so here's where it gets a little bit tricky. Iron 2, well that tells us immediately that it's the +2 ion, and that's fine. Okay, so that saves us that step. Nitride is a -3. All right, now we get these charges to equal out. So what we can do is as soon as we get that odd one, if we make that an even one, so now we got a total charge of -6 because we have 2 -3s put together. Now we're going to need 2 more +2s. So Fe3 and 2. All right, so these little numbers down here, when they're in that lower position, is called subscript. So if you were changing your font, you would call it subscript. Right? Say you were typing it. Right? If you want to put it in the exponents position where we put the charges, that's called superscript. Right? So there's your formula for iron 3 nitride. Last one, K3P. All right, so K3P. So that means I got to draw 3 Ks, and we only have one P here, so we can draw one of those guys there. All right. Now we know the name here is phosphide. It's our nonmetal, and -3, and you can find that -3 in the big periodic table we made last week that you filled in yourself, or just look at the periodic table that you've been given. Now, potassium has lost its 1 electron, so it's going to take 3 of those guys. All right. Roman numerals. More than one charge? Nope. So, just potassium phosphide. And if it helps you to remember, to slow you down a bit, to write each one in color, then do that. It's an extra step, but sometimes we've got to slow down to speed up. So those are the answers to the homework question and questions, and I hope that helps to prepare for tomorrow's resurrection quiz. Remember to review your definitions of the different particles, and a quick recap, which I'll do right now, on periodic table. So if we look at our periodic table and we see sodium, and in your periodic table we see an 11 and a 22.989 ... Okay? So, just round this off. Alright? We're going to round that off to 23. So, this one here is the atomic number. It's always a whole number. That's number. Okay, so that tells us immediately that there is 11 protons, and since an atom doesn't have a total charge, that means you have to cancel out there too. So 11 electrons. All right. Now electrons are really, really lightweight, so they don't contribute to the atomic mass, and that's this number here. What gives an atom its mass is its protons plus the number of neutrons. So, the number of neutrons is equal to the atomic mass, the big number, minus atomic number. Alright, so 23 minus 11 equals 12 neutrons for this element, and that's how you figure that out. Alright, I hope that helps too. Study up, put some effort in, and I look forward to seeing some major improvements from today's results in our resurrection quiz tomorrow.